Alright, so our goal today is to perform operations with functions. What's an operation? In math, what's an operation? Yeah, we're not physically like tearing your organs out and operating on them.
Is it like when you use like minus, division or subtract or multiplication to finish the equation?
Exactly. Those are operations. So in math, addition, subtraction, multiplication, or division, to simplify an equation, to solve an equation, to work with functions, those are considered operations. So that's the part we're going to do today. Tomorrow we're going to look at something called a composition of a function, and we'll work with that part tomorrow. But today we're going to do with just the operations. So power functions, we have been working with exponents for both chapters 5 and chapter 6. Chapter 5 were full number exponents. Chapter 6 have been the fractional exponents. So a power function is a function in the form f of x, that makes it a function, remember back to that function notation, equals a times x to some kind of power or exponent. So the a part is going to be any real number. The b part, that's the exponent. That could be a rational number. And remember, a rational number means it could be a fraction. It could also just be a whole number. But the ones that we'll try and work with are those rational exponents that we're going to continue to use. So a power function, f of x equals some kind of number with a times x to get the variable, and then to an exponent. So in the chart down below, there are the 4 operations that Sam just talked about. And we're going to see if we can now use functions and the operations to combine them together with one of those 4 operations to create a new function. So it says let f and g be 2 functions. A new function h can be defined by performing any of the 4 basic operations. So you have to have 2 functions in order to use the operations. Just like you have to have 2 numbers. If I want to use any of those operations, I have to be able to add 2 things, subtract 2 things. So it works the same way with functions. We're going to have the function f of x, which is 3x. So up here it gives you the first one. And then the other function is g of x, and that would be x plus 3. So when we add them together with the operation, we create a new function, and we just give that a different letter, h of x, because it can't be an f or it can't be a g, because they're already referring to those 2 other equations that are up there. So that's why we just call it h of x. So it says we're going to take f of x plus g of x for the addition. So literally, you're going to take f of x, which is 3x, plus g of x, which is x plus 3. I'm putting them in parentheses to kind of isolate them. So you can see that you have 2 functions that you're adding together. What would my new function be if we add them together? Virginia?
4x plus 3.
Yeah, you get 4x plus 3. Add your like terms, now we have a new function. And again, it's just called h of x. Just to represent a different function that we formed from adding the first 2. So that's it. Like, that's the addition. Subtraction, pretty much the same, except now you're subtracting the 2 functions. So we have first our f of x. You're subtracting g of x. The parentheses are so important with subtraction because you need to make sure that you're subtracting both terms, not just the first variable. So we're not just subtracting the x, but we're subtracting the x and the plus 3. So if we combine those together, what's our new function? Sam?
2x minus 3.
Yeah, so we've got 2x and then minus 3. Remember that negative distributes to both parts of the parentheses. So the third one, multiplication. Again, like kind of just working the same way. Now we're going to multiply these 2 functions together. So we have f of x, which is 3x, times g of x, which is x plus 3. Paige, what do you do to multiply these?
You would distribute the x.
Okay. So here's another case, parentheses, so important. Because that 3x gets distributed with the x and the plus 3, not just the number that or the variable it's sitting next to. So Paige, our new function is
3x squared plus 9.
plus 9x. So that new function is 3x squared plus 9x. So the last one is division. There's 4 operations: addition, subtraction, multiplication, division. And we're taking f of x divided by g of x. So we would write f of x, which is 3x, divided by g of x, which is x plus 3. Can this be simplified?
Yes.
Yes,
There's
no.
no seven
Oh,
bars.
yeah.
Is it? Why not?
There's no 2 bar, like there's no hx equals and then the actual answer bar. So
Oh.
there really has to be.
She's using like, hey, I mean that's using your resources. She's saying, well, all the other problems had a separate
Oh.
answer, and this one doesn't. So like, hey, that's.
I mean, am I wrong?
Yeah, you gotta use your logic, right? So, I mean, based off of her logic, it seems pretty correct because they did leave you an extra space to simplify it. Why doesn't this simplify? All right, I think you said no. Because it doesn't. Well, why can't it just cancel those x's? They're both x's, they should cancel.
3x.
Yeah, so this is a 3x, the one on the bottom is an x, and that one is just a 3. If you're canceling, like high school students seem to get like cancel happy. You just want to cancel everything to make like the problem just pretty much disappear. If this said x plus 3x, and you were able to add them together, then you could get 3x over 4x, and they would cancel. But if there is an x and a plus 3, I can't cancel one if I can't cancel it with the other. So whatever you do to one, you must be able to do to the other term. If you can't do it to both, then you can't cancel at all. So don't get like over cancel crazy. Don't force things to cancel when they really can't. Or use your logical reasoning and say, hey, there's not an extra blank there, so this must be the answer. Except that might not be on a test.
Yeah.
Yeah. But now you'll remember. Questions? So no canceling, this is your final solution. So think of this as a group. If I do it to one, we've got to do it to both. All right, so that was like the little kind of basic rundown of the 4 operations. Obviously, we're going to start working with exponents that have powers of a fractional form. Makes it a little more interesting. And we're also going to talk about domain and not range, but just the domain of these. So not range, just domain. Poor range, I know. Range, you have to look at the graph, and then you got to use a calculator, and I mean, we don't use those.
Calculators make your life a lot easier. So
You think so?
I hate calculating math.
So we're just going to focus on the domain and avoid the range right now. At the end of the chapter, we'll give range a little bit of love. But this says the domain h. Remember, h is your new function. So h is the new function. So the domain of the new function consists of x values that are in the domains of the original functions f of x and g of x. So pretty much when we're looking at the domain of the new function, we have to use the old functions to find the domain. So the domain is based off of f of x and g of x and kind of where they overlap. So in order to get a domain of a new function, we're going to use the old functions because that's what created the new functions to begin with. The second part says, additionally, the domain of a quotient does not include x values for which g of x equals blank. So if we have a quotient, and the quotient we just did was f of x divided by g of x. So that was, was it 3x over x plus 3? So 3x over x plus 3. So it's saying that whatever g of x is, because it's in the denominator, it does not include x values that do what? So if we have a fraction from yesterday, think about what has to happen with the denominator of a fraction or what values you can't have. Aaron?
The denominator can't equal 0.
Right, the denominator is not allowed to equal 0. So anytime g of x is in the bottom and you're dividing, that g of x has to exclude values that make it equal to 0, or a domain has to exclude values that make it equal to 0. So the domain is using the original functions f and g, but also if we're dividing, the domain has to exclude anything that makes that denominator equal to 0. So on the next page, there are a bunch of examples that we're going to work through, just kind of looking at operations and trying to remember the properties of exponents and applying it to our operations. And then we're also going to look at some domain and range as well. So before you start the problem, I want you to get the domain and range of each individual function so that when you go to find the domain and range of the answer, you already have the domain and range of each function kind of listed. So your homework tonight, you'll have like 8 problems pertaining to like 2 functions, or 6 problems pertaining to 2 functions. So look at the domain and range of the functions that they're giving you, and kind of analyze that first before actually answering the question. So the first function, f of x, is 2x plus 7. What kind of graph is that? Okay, it's just a line. Yeah, that's mx plus b form. Okay, what's the domain of a line? Hey, that domain would be negative infinity to positive infinity because it's just a line, mx plus b. Line goes on forever, left and right.
Wait, so that's the domain.
That's the domain for f. What type of equation or function is b?
Parabola.
A parabola, and Ethan, the domain of every parabola is?
Same.
Yeah, it's the same as a line. Negative infinity to positive infinity. So both of my domains are negative infinity to positive infinity. That means there are no restrictions, so that makes our domains easy to find in the end as well. Alright, so the problem wants us to take f of x plus g of x, and then letter b, take f of x minus g of x. So see if you can try and find those 2 functions. So f of x is 2x plus 7. G of x, 5x squared minus 6x plus 4. My new function h would be that simplified form. So we've done this, like in chapter 5, we added polynomials together. It's just they didn't tell you that you had 2 separate polynomials. You just already had it in addition form and you combine like terms. That's the same thing here. You're just combining like terms. What do you have, Sam?
5x squared minus 4x plus 11.
That's 11. So when you go to get the domain, don't use the answer to find the domain. Use the original domains because that's how the answer gets its domain. So the original domains both were negative infinity to positive infinity, so this domain would be negative infinity to positive infinity.
Can you add equations if they don't have the same domain?
You can, yes.
Okay. Well, then how do you know the answer?
You would kind of take the overlapping part of the domain and use that as the answer. So letter B, we have f of x minus g of x. So just be careful here. So 2x plus 7 minus the entire 5x squared minus 6x plus 4. Sarah, what do you have for h of x?
H of x, I have negative 5x squared plus 8x plus 3.
And what's that domain?
Negative infinity.
Right, so still the same domain because they were negative infinity and positive infinity in the beginning. Questions? Alright, so if you look at, we're right. The second group of problems, now we have some rational exponents. So we have 4x to the 1/2, negative 9x to the 1/2. And again, you're asking us to add and subtract. So before you go to the adding and subtracting, look at each function that they're giving you and think about the domain. How do you actually write x to the 1/2? Like, what does that really mean? What type of
The
equation?
square root of x.
Nice. So that really is 4 and then the square root of x. So that means this one is really negative 9 and the square root of x. If you think about it as a square root, it might help you remember the domain a little easier. So yesterday we talked about square root graphs in the domain of square root graphs. So this was from yesterday's little packet of homework. Or a little packet of notes, I should say. Does anybody remember if you have a square root, what has to happen with that square root, Paige?
The square root has to be greater than or equal to 0.
Right, whatever's underneath the square root has to be greater than or equal to 0. Now it's just an x, so x has to be greater than or equal to 0. So Paige, what does that mean as an interval if x has to be greater than or equal to 0? How would we write that in domain form?
0 to positive infinity.
Right, so that means the domain is 0 to positive infinity, a bracket with the 0 because it's greater than or equal to. So if x is greater than or equal to 0 as an interval, that means it starts at 0 and it goes to infinity. And that's the same for this one as well. So 0 to infinity. So the domain, because it's the square root of x, you can't have negative numbers under the radical. So that means 0 to positive infinity. So now we can try and add them. We've got the individual domains that'll help us to get the answer. So we've got 4x to the 1/2 and negative 9x to the 1/2. So those would be our two functions. Can you add these together? Yeah. Why can you add them together, Sarah?
Because they have the same power.
They have the same power. So both x's have the same power to them. They're like terms. What are you actually adding together, Sarah? The 4 and the negative 9, so that makes negative 5 and then x to the 1/2. Remember, the x to the 1/2 doesn't change. It's a like term. If I added 4x plus 9x, or 4x minus 9x, I get negative 5x. The x just kind of carries along. That's the like term part. That's the part that's the same. You don't change that. So you're not adding those exponents. You're not doing anything with those exponents. Okay.
Could you leave that as negative 5 square root of x?
You could, but considering they gave it to us as an exponent, the answer usually correlates with however it started with. So if it started with a radical, then my answer would remain a radical. And then the domain, well, both domains were 0 to infinity, so this domain is going to be 0 to infinity, including the 0, so bracket with the 0. So the second one we're subtracting. So we have 4x to the 1/2 minus negative 9x to the 1/2. So David, what would that new function be? And the domain would be? Yep, 0 to positive infinity. So all four of those examples dealt with adding and subtracting. Are there questions with those? Aaron?
Also, would it have a square root equation that would be 0 to negative infinity?
If there was a negative already underneath the square root, so if there was a negative underneath, then it would be from negative infinity up to 0. Because this is like changing your answer underneath. So if I put negative numbers in, then it makes the answer positive. Good question. Other questions? So the other group of problems deal with multiplying and dividing. So we did 4 with adding, subtracting. Now let's think about what happens when we multiply or divide. Again, before we do that, list the domain. So I want you to list the domain of each function first prior to you working through the problem. So Isabella, what's the domain of f of x equals 6x?
Me?
Yeah, yes, sorry.
Oh, okay. The domain of f of x equals 6x. Would that be a like odd polynomial?
Mm-hmm.
So that would be positive infinity, negative infinity.
Yep, negative infinity, positive infinity. Yep. And then we have x to the 3/4. How do you write that? Isadina?
Would you write that like put it in the cube root of that? No, I mean the fourth root of x.
So that's the 4th root of x.
to the third.
Good. Cute. Nice. So if you have a 4th root, what can't you have underneath the radical, Sam?
It has to be greater than 4. No, or is it greater than 0?
Has to be greater than 0. So any even root always has to be greater than or equal to 0. So whatever's underneath, if it's an even root, a 4th root, a 6th root, a 10th root, a square root, whatever's underneath there has to be greater than or equal to 0. So that means just like above, we would have from 0 to infinity. So Sam asked, can you do it if the domains are different? Can you solve the problem? Yes, you can. But your solution for your domain is going to be where they overlap. So this goes from negative infinity to positive infinity, but this one has to start at 0 and go to positive infinity. So my domain would have to be then from 0 to positive infinity, because that's the part where they overlap and then carry on.
So basically the one that doesn't go on.
Exactly. Yep. So the one that's like more restricted is usually your solution. So this one that says it wants us to take f of x times g of x. So if we're writing this, f of x is 6x, g of x is x to the 3/4. How do you actually multiply these together? Sam?
Will this become 6x to the 3/4? Or like 6x with 5 to the 4th?
You're on the right track, I think.
Yeah.
Ethan?
Would you do, would it be 6x to the 7?
Why?
Because 6x has the power of 1 and 4 over 4.
Very nice, Ethan. So you said 6x has a power of 1. If we're adding the exponents together, this 1 really becomes 4 over 4. Adding it with 3 over 4, you have to have like denominators in order to add them together. So that means our 6x would be 7 over 4. So Sam, you were on the right track. You knew you had to get those added together, but we need to have those like denominators with the fractions. So 4 over 4 plus 3 over 4 gives us 6x to the 7 over 4. Remember, this 6 is the only number up here, and then you're just combining the exponents to get that x together. So the domain is from 0 to infinity. That would be the part that's overlapping, the part that they share. So both of them go from 0 to infinity. The second one, we have f of x divided by g of x. So 6x divided by x to the 3 over 4. Caitlin, do you remember what to do with these exponents when you're dividing? So what do we do with these exponents, Caitlin? Sorry. Caitlin says she's not sure. Anybody remember what you do with the exponents? Kate? Sorry, Kate. Yeah, you subtract them. So now we're subtracting instead of adding. So remember, when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. So Kate, if we have 1 minus 3/4, that just leaves us with 1/4. So 6x to the 1/4. How about this domain? Kate?
So it'd be 0 to positive infinity.
It would still be 0 to positive infinity. H?
I mean, I'm just taking a shot in the dark here. But would it be parentheses on both sides instead of a bracket?
Why?
I don't know, because the other one has a bracket, and then you said this one's different, and that's only like different. So
So because you have an x in the denominator, remember now we have that denominator.
okay.
So we said that domain, where is that guy? Right here. When your g of x is in the denominator, it's not allowed to be 0. So because it's in the denominator, it can't be 0 because it would make the fraction dividing by 0. So that's why that one gets a parenthesis where the other one does not. So it's not allowed to be 0 because I can't divide by 0. Questions? I don't know what time this class goes to.
11:10.
Oh, yikes.
Time is it?
Apparently it's 11:10.
Oh no.
I didn't get to those last 4 problems that I wanted to. All right, so your homework is on page 432. You're going to do 3 to 19, all of them. And then I'd like you to take a peek at 20 to 27 and try those. So kind of look at those, see what's going on. We're starting over for the semester. Anybody interested in trying 8 or 17? Tyler, 8, Grace L, 17.
Isabella, I tried it on.
Why did it fit?
No. I tried to tap it.
I didn't think it was. Like, I'll